In this problem, we're given a price-demand equation that relates the number of TV sets that are being produced with the price that we can price them at. And a price-demand function, again, gives you this relationship. So if you know the number of TVs you want to produce and sell, this will predict the price at which you're going to need to price them in order to sell them. So if you wanted to see what would how many you could sell at a given price, you could solve this equation for X and determine the number of TVs you could sell at that given price. Or if you knew how many TVs you were going to make, you could figure out how you're going to price them. This particular problem asks us to calculate the marginal revenue at a particular production level. 2,250 TV sets are apparently being produced and sold, and the question is, how fast is the revenue changing? So there's a little bit of vocabulary here. Marginal revenue is equal to the rate of change of the revenue, so the derivative of the revenue function. So I guess the first thing I would need to do in this problem is build a revenue function. That is fairly straightforward. Most of the work has been done for us. The revenue is going to be the price times the quantity, and if I hadn't already done so, I would need to produce a price function that depended on X and a quantity function that depended on X. But these were given to me. The price is negative 1/30 X plus 300, exactly the price demand function. And the quantity of TV sets as a function of X is exactly X. That's what X measures, the number of sets. So this is the revenue function. To finish this problem out, I need to calculate its derivative, evaluate it at 2,250, and then talk about what that number represents. Since I'm going to be doing some calculus on my revenue function, I think I will rewrite it once. I'm just going to multiply this out. I could use the product rule the way it sits, but it's simple enough to multiply this out, and with that, no special rules are necessary. The derivative of the revenue 100. The 2 divided by 30 gives me a 1/15 in there. So at a production level of 2,250, just calculating the number I need to interpret, I will get, simply plugging into my derivative, a number here. If you do the arithmetic, this comes out to be 150. And now I need to interpret this, and the best place to start on that is with the units on this. This doesn't need to be a memory game. The units on any derivative is going to be the units on the function divided by the units on the variable. And again, that comes from the simple fact that a derivative measures, among other things, the slopes of tangent lines, and slopes of lines are simply rise over run. Change in the function value divided by the change in the independent variable value. So that calculation, rise over run here, is going to have units of the function divided by units of the variable. In this case, the units on the revenue function is dollars, and the units on the X value is TV sets. So this 150 measures, has units 150, let's see, dollars per TV. So I'll put the dollar symbol right there, divided by TV. All right. So the revenue function is changing at $150 per TV when 2,250 TVs are being sold. So how to interpret this? Well, this means that the revenue is increasing, and it's increasing at a rate of $150 per TV when 2,250 TVs are being produced. Another interpretation of this would be that to talk about what would happen if I changed production. If I increased to 2,251, the total revenue should go up by approximately $150. So the revenue for 2,251 would be approximately equal to $150 more than